Rack-based heat containment. Well, and when you start getting into the rack, this is the area of your data center where you try to set up a barrier, cold to hot. It's very important that good rack hygiene is taking place. Variety of different products exist that are out there in the market around sealing that front to back barrier. And obviously the blanking panels make a big difference in there. A lot of confused airflow in racks, meaning there's a lot of products out there that, we're talking about a front to back airflow, but there's a lot of products out there that just, they don't go front to back. They do something else. And you need to manage that airflow because that can create, a localized hotspot, and even that piece of equipment can be starved for air or receive warm air. As you see here, if anybody's familiar with some of the Cisco networking equipment, that's always a problematic point for Cisco equipment moving in a front-to-back airflow environment when you put in an enclosure. Many baffles exist for those type products to make it front-to-back, including products that are normally exhausting out the back, but IT departments like to mount them in the rear because of the connectivity requirements. Well, you need to be able to manage that airflow as well. Many products exist. As well as cold lock and other type brush strips, all good hygiene for the rack. Why rack-based heat containment? Well, stage one is a chimney that directly connects to the rack to exhaust that heat and throw it up into that stratification layer without it having to just be exhausted straight out, vertically out the back of the rack, and then normal heat rise, try to get that heat up into the stratification layer. Stage one, we see it as a way to facilitate that stratification return concept. Stage two is that same chimney is actually connected to a return plenum. And when it's connected to the return plenum, and actually in stage one as well, you can make that active or passive. Passive systems exist, active systems exist. We do them both regularly. And when it's active, you can look at controlling it via temperature or via pressure, whatever is really your driver. So why implement it? Well, all those strategies for maintaining that front to back airflow and the strategy for exhausting the air out of the rack gives you really that high separation between hot and cold, and is going to really dramatically improve your capability and your predictability in your data center. And it reduces the overall amount of air that you need to supply to your data center to be able to cool the IT equipment. On average, if you would add up your CFM in your data center that is being supplied by your crack units and the amount of CFM required by your IT equipment, on average we see 130 to 140% difference. And that's really a significant difference, meaning that 40% is oversupply. That's available to either be more efficient in your supply or handle additional load without doing radical changes to your data center. And obviously, the end result is balancing that supply and demand. Obviously, this is scalable. It's flexible. You can install it on an existing data center. We've done that multiple times with multiple vendor products, even on our products in motion, to be able to put on this chimney-based system, connect it up to a return plenum, and start drawing the air directly back. Fits on all third-party racks, and it's obviously fits on our rack as well. We have a bunch of different CFDs, but I just wanted to capture one and throw it up here to be able to speak to it. But here is a working data center. This is a working data center in a traditional hot aisle, cold aisle. It's got 8 cracks along the aisle. You're looking at a plan view, and I'm taking almost like an MRI slice, 4 feet off the ground. What does that look like? This is an operating data center. This is all open. There's no containment, open air. As you can see, the hot aisles, well, go figure, they're hot. Right? The cold aisles are cold. This is with all 8 crack units running. Over here on the HCS design, I've actually shut 3 off. And I'm actually starving the IT equipment by 3%. I mean, if the IT equipment's asking for like 89,000 CFM, I'm giving it somewhere in the order of 85,000 CFM. So I'm starving the IT equipment, and I'm able to maintain inlet temperatures and not exceeding any inlet rack temperatures. So that just gives you an idea of the difference of performance. One of the other obvious notes, look how much more room in the data center is cool. A not so subtle other note, this happens to be in hot aisle, cold aisle. Well, in a containment world, you can set the racks up in a circle if you want, right? Or you can go back to the legacy data center. How many people remember 10 years ago when all the data centers were front to back on the rows, right? That was historically how it was set up. Well, remember I also talked about cold aisles growing 6 feet, consuming more footprint? I can go back to one of those 10-year-old data centers. I can install a heat containment, and I can make that a higher performing data center than any open frame cold aisle, hot aisle arrangement, because now every aisle becomes a cold aisle supply aisle, and it's 4 feet wide. That's equivalent to an 8-foot cold aisle in today's design. So you can see some significant gains in footprint as well as performance. This just gives you that same data center little idea. Remember the chaos confusion we were talking about versus a predicted data center and the heat containment? You can obviously see where all the cool areas, you can see where all the warm areas in the 3D view of a traditional data center. You really have to start peeling that apart. And I could easily point out the bypass air, the recirculation, and the stratification problems in the data center with a CFD. And if anybody was wondering, this is a Six Sigma CFD package that we use for a regular basis. Obviously, rack-based heat containment challenges, right? Like I said, nothing's without challenges. Well, you need a return plenum. A lot of data centers don't even have a drop ceiling, let alone a return plenum. And is it rated? Those are some questions. And then how do you have to actually connect a crack up to the ceiling? And in fact, I've even been in many data centers, they're actually halfway there, and they didn't even know it. Where they've already got the cracks connected up to a drop ceiling, they've got the data center loaded with egg crates. Perfect application for heat containment. And then the next thing is you imagine with a chimney coming off the back of each IT rack, row perpendicular wire trays need to be in the main aisle. They can't be over the racks. As you can see, the whole methodology for our type of containment is you still have wire trays available to be over the racks, and you can actually waterfall into the racks, but to run one perpendicular, kind of difficult. This just gives you an idea of a site that we have installed. As you imagine, over the IT rack wire trays, not a problem. Go in the other direction, it's a problem. This was a site that spent a lot of time aligning their floor tiles to their ceiling tiles. And as we had a IT rack sitting on the right floor tile, I wanted to make sure I got into the right ceiling tile. So you can see the actual chimney hooking back around, entering underneath the underneath the rack cable tray, and then circling back in to connect above it. And that was a collaborative resolution for one of our customers. So in summary, a lot of different containment strategies that are out there. It'll give you some of the pros and cons of those. Ideally, you want to just eliminate recirculation, stratification, bypass air. Keep in mind, you can do this with saran wrap. Right? I mean, you can go out and buy a couple nice plastic tarps or saran wrap and get some level of containment. It's not going to last long, but that's how intuitive and simple a decision can be. Obviously, it creates the predictability in your environment, meaning you have a high predictability that the cool air you're going to put out of your crack unit is actually going to make it to your IT equipment. And it's not going to be bled in with warm air, and the warm air that's going to be coming out of your IT equipment is actually going to make it back to your crack. So, several different ways to get to a containment. Ideally, the collaborative approach we see is best because not one is a laser shot for everybody. In fact, not one is the laser shot for everybody in the data center portfolio. And of course, drives efficiency and operational savings.